think that's bigger. Meeting. Okay, so I'll walk through. Oh, let's see, the click's not clicking there. There we go. So I'll kind of walk through fishery stock. Like, what is fishery science? How does stock assessment fit within that framework of fishery science? Very quick and high-level overview. Then I'll go talk about kind of the origins of fishery science as a field. I'll talk about MSY and rational fishing. This is a period when we thought math will save us all. And then the aftermath of that, which is the consequences of our overconfidence in the period. Kind of walk through, you know, kind of field developed, and then you could say fell apart. Some people would. I would say not quite. In terms of taking stock, I'm going to talk about then where are we now and where can we kind of go. So I'll look at 7 ways. I've seen people talk about 2 ways we can collect data, analyze data, think about fishery science, and then talk about our research a little bit, which is how we're addressing these questions. Then finally, I'll talk about some scientific and systemic challenges we face in doing fishery science. So what is fishery science? A whole bunch of definitions that I found. I'm not going to name them all off, but I do love the Royce one, which is fishery science is a body of scientific knowledge and a profession practiced by fishery scientists. That is really illuminating. Love it. A whole bunch of other ones, some better than others. It's not really a great definition too, I found, which I thought was odd. And it also changes over time, and it's different in different parts of the world. So Western science, Canada, fishery science is one thing. If you're up in the Arctic, fishery science is actually quite different than how we do it in the maritime region. So my current, and this will change next week when I think about it again, but fishery science, I think, is a field that's focused on quantifying how ecological processes and societies, and the societies thing is really critical to what fishery science is, how those interact to impact harvested marine species and the ecosystems in which they reside. So quantifying, again, very Western science point of view, we're heavily dependent on data collection and statistical modeling. That's how the field kind of grew up, and I'll kind of talk quickly how we got there. Ecological, I think hopefully everybody here and online knows what ecological processes, but basically biology and the interaction of biology and environment. And then societies, so different societies take fisheries, take what they see in the ecological, biological environment, and they deal with it differently. So there's different fishing methods, different technology, governances can be very different. Energy development falls in there. Pollution's a factor. Geography, history, all sorts of things in the society affect how fishery science. I mean, generally science anyway, how it happens. But how you fishery science really depends where and kind of when you are in the world. So stock assessment, it's a subset of fishery science. Really hasn't changed a lot in the last almost 50 years, what I should say. It hadn't changed from it. So it's starting to change now. Some of the central tenets, really, logistic growth is backbone of a whole bunch of the models underpinning this. And the ideas behind logistic growth came out of Belhurst, that's in French, 1838. So that's when logistic growth ideas were first contemplated. The world at that point was really a world. Technology was just 1838. Technology is just getting going. You don't really have steam engines on vessels or anything like that. No coal fire. You're still sailing. So a very different world than what we have here. This research by Belhurst was really lost for 80 years, not till between the first and second war did anybody find it again. So stock assessment itself, it's a subdiscipline of fishery science. Oops. The objective of a stock assessment is really to determine how many individuals the fishery can remove sustainably. This is a very DFO biased way to say it, but that's the objective. Comes down to what can the fishery remove without us collapsing that fishery in the long term. The focus is generally on one stock. So you just take an area, you go out and survey it, and what you try to come back with is one number. And it's also very short term. So our advice is for next year, maybe the year after. So we want to know the status of the stock now and the status next year. That is kind of incongruent with concerns 50 years from now. And so we have a lot of pressure to do this very quick thing where in the next year, whereas if you're taking that longer view, doesn't really factor in that much to this. It can factor into reference points, so I won't talk too much about that, but really my day-to-day is give me a number and I need to know what you can take next year. That's what stock assessment in Canada right now should be all about. How you do it, again, depends on the data you have, and it depends on political jurisdiction, where you are in the world of the data. So fishery science and ecology, segue to that. This is one of the things that really messed with me when I first started, because I had a bit of an ecology background at least. And I was like, what are all these things fishery scientists are talking about? And they're like the same thing. Like you get the logistic growth model, which hopefully most people have studied, and you have carrying capacity and you have population size. And so Schaefer in 54, it's a little bit different, but basically he went, okay, I'm going to do this in terms of biomass. And so unfished biomass is carrying capacity. Spawning stock biomass is your population size. And you fit the same model, more or less. It's not that simple, but we've renamed a lot of things that have a lot of overlap between fishery science and ecology. It leads to a lot of confusion and takes some time to ramp up and get between the two. To me, the biggest difference, again, is really that human dimension. So what's the main threat for a species that has a directed fishery? Well, someone wants to go eat you. What's the main threat for a marmot and Banff? Well, it's probably urban development, right? So the threats are very, very different. And that's, I think, really driven how people think about it, both between the fishery science and ecology. And you just need to have that in the back of your mind when you see how fishery science develops. And so here I'll start the history story. So the origins of fishery science, really as a science, I'm sure it goes before this, probably go back to Aristotle, I think you can actually, but really I'm starting about 1850s in Norway. And what happens is people are looking at the catches of Atlantic cod and going, why is this variable? What's going on? And so there's trying to answer that question, why is this variable? By the 1880s, kind of all of Europe, but many European countries and North Americans are taking a very active interest in this. Declining catch rates in fisheries is often the driver of this interest, right? So we're not making as much money and we're not getting as much food as we used to. There were the Challenger expeditions in the 1870s that kind of influenced marine science right across the world. And yeah, so this is happening then. The big oceanography and fisheries institutes don't quite start at this period, but the concept for them and the building of them does. So this is the oceanography building in Monaco, which I was at last summer or something like that. It's really cool and blew my mind. I went to see race car track. Went to that place and I was like, wow, that is really nice. Beautiful building, really tricked out, lots of old stuff. Like these books that you can't see here, should be using the mouse for you guys. These books here, I took a picture of them in there. They're all original Challenger books from the Challenger expedition. They have all sorts of stuff in the lab, kitted out from gear from there. Really cool spot if you're ever fortunate enough to be in the area, pop in. Focus of fishery science at this point, aging and tagging fish is a big deal, which still is now. And again, one of the big questions that was floating around was, maybe you should wait till after the fish spawn to catch them. So does fishing before spawning really matter? So the questions haven't changed a lot. I think we could still ask that question of several fisheries and not know the answer. So how does biology and ecology impact variability in catch? Really, the first reveal here is Johann Port. I think that's how you say it. He founded ICES, the International Committee for Exploration of Seas. He was critical to that. And he noticed that the survival of young fish is really critical to that. So when young fish don't survive, your fishery catches are going to decline. So this gets at the recruitment idea in fisheries that has underpinned everything since his time, for sure. So then I'm going to do a little sidebar here, talk about some things going on in Canada around this time. So 1867, Canada becomes Canada. The Fisheries Act was actually one of the first acts the government put through at this time. So in 68, the first Fisheries Act is there. It enshrines a lot of things that now it talks about controlling exploitation. Not in that language exactly, but controlling removals and effort. So things we still do now, I think there's even some stuff about habitat in there, habitat. Things that we still talk about now were in that first Fisheries Act. Other things going on. So on the left here, this is on the West Coast. This is how the First Nations would catch salmon at this time. Of course, with everything, so in this period, they take the brunt of things. It's transitioned from this kind of a fishery to the very European colonial kind of fishery, where we're just catching as many salmon as possible area. And of course, the First Nations probably done and happened on the East Coast before that get marginalized at the time. Other things going on. So we're fighting with the US. This is 1867, not fighting, arguing with the US, I should say. But we are only 50 years after the War of 1812, and we were actually fighting with the US. So we're about as close to the War of 1812 as you are to the First World War here. So we're like, US and us are not very happy with each other in terms of fisheries, and you don't have 200-mile limits yet. So there's a lot of conflict and boats getting taken in and people get arrested in this period. So that's happening already. Fighting on the West Coast about seals. There's lots of things related to salmon, because on the West Coast, especially, even the Japanese are involved with that because the salmon are moving. Japan, US, and Canada all have a lot of interest in Pacific salmon. And so a lot happening in that side of things. I think that's all I want to say there. Oh, I should mention a picture of the fellows. I believe this is E.E. Prince, who was the first Dominion of Canada Fisheries Commission. So he was basically the first, I would call him, Minister of Fisheries in Canada. And this fellow here I'll come back to is A.G. Huntsman, who I'll talk to him in a couple slides, but he was a big name. There's still Huntsman or DFO for people doing world-class marine sciences. And then there's an angry guy. I don't know who he is, but he looked really mad. But he wasn't happy to be pictured. So I'll go 1900s to 1949. So rapid technological advances here. We go from the Blue Nose, which was 1920s first mission, I believe, to vessels that have coal-fired. So rapid technological advances here. And we actually start to move from salting to freezing, which is a big jump too. So now you're able to freeze fish fillets and send that around. So that makes a big difference. But you're fishing year round, you can freeze it and ship it off year round. But we have two wars and a depression in between. Don't talk much other than this kind of gives evidence, especially to Bedford and Bolts, we'll talk about in a slide or two, about the fisheries do actually impact stocks. It was still a big question whether they really did or not. And so with the relaxation in the First World War and Second World War fishing, especially Second World War, you can see fish stocks rebounding across the Atlantic. Yeah, and then there's interest. So there's starting to be interest is how can we get the most out of the oceans as we can? So how can we optimize our catches? This is more towards the end of this period, but the 40s really were kind of a hotbed of debate around this. And mathematical models start to pop up. So here's a picture here. MSY theory is basically you fish the population till it's at half its carrying capacity, unfished biomass, and you will get the most out of that population that you can. So this is maximum sustainable yield. And we talked about this pretty much for a whole lecture. It's a terrible idea, but it's how fisheries, and it took hold. It was really a politically driven thing. The idea is you fish the surplus of nature, right? Nature is giving us this extra fish that we can. There's a wonderful book by Finley, 2011, Thermal Finley, All Fish in the Sea, that really talks about MSY and how the US State Department and Wilbur Chapman in particular, who was a scientist, really drove this. The Schaefer model too was involved in pushing MSY theory. And it still reverberates out throughout fishery science today. It's still a big deal. We still talk about MSY all the time and drives some people a little crazy. So in Canada, so a few things I want to talk about here. So this first one is this interesting, I didn't know too much about this, but I'll get to why I knew a little bit. So there's Edith Berkeley. She was out west at the Nanaimo field station, which early 1900s, Nanaimo field station pictured here. It's one of two St. Andrews field station pictured here. They're the first two real oceanographic or marine science institutes in Canada. So Edith was interested in polychaete worms and studied in the West Coast. She then had a daughter, Alfreda Needler, well, Berkeley at the time. And yeah, I should say Edith published like 100 papers on polychaetes. Her and her husband were really into that field and had worked with the predecessors of DFOs. So Alfreda Turner is her daughter, Berkeley, and she actually realizes there's sex transitions in shrimp on the West Coast and oysters. So you can change sex during your life. So she's one of the first people that sees this in marine species. She ends up marrying Alfred Needler, whose name may be familiar if you ever paid attention to Coast Guard boats. It's a good reason you don't want to be too famous because you might get tied to one. So Alfred is really running a lot of the show in maritime regions. He's one of the first directors of several of the stations in the region, and his interest is in haddock and oysters as well. So him and Alfred are both interested in oysters. So they then have two kids who also do marine science. I don't want to get too much into it, but there's at least three generations starting from Edith Berkeley that have really had big influence. George Needler, there's a George Needler boardroom at DFO, is one of their children. And then I coached Alex Needler, who I think is Alfred's great grandson at hockey. And he's here at Dal now doing math. So we should try to get him back in so we can get the chain going again. I tried but failed. So that's why I'm kind of interested in him. I know the hockey days. There's also A.G. Huntsman, who's really a big name here, I mentioned him before, but he comes up with the freezing of fish fillets. He kind of figures out how to do it. And he gets his own stamp for it. So I don't know how many fishery scientists in Canada have managed to get a stamp, but Huntsman's done it. He has a big seminar that happens every year with the award at DFO. He's the first director, I think the first director, really early at the St. Andrews Field Station. There's a Huntsman aquarium over there, there's a Huntsman Center over there. So he's really one of the big lads back in the early days. He's very important to how fisheries built up, fishery science built up in Canada. So we go to I'm going 1949 because I want to say Newfoundland comes into consideration here. But this is, again, this rational fishing versus MSY, this battle takes shape. So Michael Graham, he's UK scientist, and he's about this rational fishing idea, which you will still hear about today. And it's kind of controlling fishing effort, and fisheries will become more. That's his idea. Whereas you have Wilbur Chapman, who I mentioned earlier, and basically the idea from MSY is don't restrict the fishery until something bad happens, because MSY will solve the problem. That's kind of the two angles that are being pushed through. And so Beveridge and Holt, if anyone knows stock-fruit relationships, here's an example of one showing that they actually aren't a thing, but it shows a stock. They did a lot of work on stock-fruit and all sorts of basic mathematical fishery science. So their book is a classic. Ricker. So Ricker was a Canadian. He also worked on recruitment and stock size and a whole bunch of other things. I'll talk about Ricker more in a sec. And then Schaefer was more, and I put Ricker more in the Beveridge and Holt category, but as a Canadian, he's in between the Canadians and the Americans, so I like offset there. And then so Schaefer is working for Chapman on tuna, really drives home the MSY, and they win more or less, at least in terms of international fisheries. But these papers, all very mathematical. Ricker's calling fishery science more or less biological statistics of the ocean, and really drive the mathematical interest in the field. There's also in this period, amazing because of technological freezer trawlers everywhere. Start to get freezing technology offshore, I'd say, by the latter part of this period. And so what you see, so this is just cod, this is from Rose's book. Factory freezer trawlers are everywhere, and it's pretty much a free-for-all in the ocean. So this picture is probably the best one to me. So the big peak is the foreign fisheries in Canada. I don't know if the years come up very well for folks if you're not online, but from 1960 to about 1975, the foreign fleet fishing cod off the coast of Canada took way more than the Canadian fishery. Well, not even close. It was 1 year, like the total landings, about 1.3 million tons, which is a lot of fish. So, and this is the MSY logic. Well, we can fish it until it's in bad shape. A bunch of this was the Russians. What do the Russians care about taking fish from Grand Bank in Canada or somewhere else? Right? And so this really drives the idea for countries to expand their territorial waters. This is all happening in this period. Even before this period, there was talk about this, but driven in large part by foreign fisheries. The Latin Americans were really concerned about the U.S. We were really concerned about European influences here. And so everyone wants to buckle down and take control essentially of their continental shelf. But what comes up out of this, the law of the sea really wasn't that far until the 90s, which is wild. But the law of the sea through the UN, the UN Convention on the Law of the Sea, and the 200-mile limit comes into place, and that comes into place in 1977. And I think this one shows it well. Here's 1977 in Canada. And one thing that really stands out to me is the foreign fleets are not fishing cod already. So this cod is effectively collapsed already. So that's, to me, the first collapse of cod in Canada. And it was a little bit silent because there was a good rebound after that. So folks in Canada that are interesting, so we have this huge overfishing capacity from foreign fleets. Newfoundland becomes part of the Confederation. They may regret it. But Newfoundland comes in. And so three people I just want to highlight here from this period, and to say there's millions of people. So there's tons of other scientists, so this cloud of people here who are doing work on basic biology, fishery science, and yeah, it's really, the field's really expanding. There's a lot of research going on. So William Ricker, he's kind of the guy in Canada. He's the rock star, I'd say, of Canadian fishery science at this time, looking at stock-recruit relationships and many other things. And he's working out west. Wilfred Templeman, is working in the Newfoundland region. He's kind of directing everything up there. If you notice, again, another guy that has a boat named after him. Templeman is one of the Coast Guard vessels. So he's kind of, I think he did authored 250 papers, I believe, on marine science. So he's done a bit of work. And then there's Jack Valentine, who I mentioned, who isn't really fishery science, but if people are familiar with the experimental lakes area in Ontario, he's the guy that got that going. And that's not fisheries. But what came out of that experimental lakes area was really, we need to focus on the ecosystem. We need to think about ecosystem considerations, just generally, think about the holistic picture. And so I'm sure the thoughts that came out of the experimental lakes area filtered into the fishery science world, and people started thinking, oh, we should think ecosystems. That's a good idea. So then we get to the 70s to the 1990s. We have the Gadioid outburst. This occurred just before the 200-mile limits are imposed. And I think this really led to a false confidence, especially in Canada, that we could ramp up our fisheries again. Because really 15 years, I say approximately 20 years later, the cod stocks have basically totally collapsed. When I was out in the survey in 2010, this was an immature cod, tiny little thing. The pen tip hopefully shows it there. And it's not, Atlantic cod isn't the only one that collapses, but it's kind of the poster child for collapse. And several fisheries across the globe do. Bunch of postmortems start to roll in on MSY, even in 77. My favorite one that I'll just read is the Gulland one, which Ray Elmore quotes John Gulland saying, MSY is a quantity that has been shown by biologists not to exist, and by economists to be misleading if it did exist. It is the key to management or modern fisheries management. And that kind of gets at where the field, this is, you had a belief, you went with it, it got enshrined, and then we're kind of stuck. So at the end of this period, the 90s, where alternatives to traditional fishery science start to come to the fore. And people are starting to question scientific integrity of fishery scientists. So again, what we have here is the cod collapse. I'm going to circle back to this a little bit, but essentially 35 to 40,000 people are laid off, billions of dollars of subsidies kind of have to come into the region, leads to a big exodus of people from the region. When I was growing up in the 90s when this happened, I was in high school, I guess. And you wouldn't stay here, you were going somewhere else when you were done school. So it led to this exodus from the Maritimes region, Atlantic region, I should say, which I think is just, we're just recovering from. It's just, we're getting back on our feet now. It's a lot of the marine sciences community building up here, but it's helping. Two people really probably don't get enough. You may have heard of Ronald Sparrow a little bit. So this is the Sparrow decision. These two people I want to mention is probably going to change how we do fishery science in the next decade. So Ronald Sparrow was fishing in BC and got arrested in 1982, I believe it was. He was fishing in a traditional river, I think it was off of Fraser, but I shouldn't say for sure. And so he got arrested. And so this led to what's called, his case went to the Supreme Court. It led to the Sparrow decision, and the Sparrow test came out of this. And effectively the two things. So this was all about Indigenous rights and when the government's infringing on Indigenous rights. And this decision, two things that come out of it that we deal with in fisheries, and the government deals with more generally, are Food social ceremonial fisheries really come out of the Sparrow decision. So if you hear people talking about food social ceremonial fisheries, that is their right that comes out of the Sparrow decision. The other thing is the duty to consult. And so you'll see that any big projects need to consult First Nations. That comes out of the Sparrow decision as well. And it's interesting stuff, but interesting one to read. Then there's Donald Marshall case. So Donald Marshall is from Member 2, just up where I was growing up. And Donald Marshall has the craziest life you can ever imagine. If you don't know who Donald Marshall is, you should look him up. Very interesting. He's arrested, I think in the 90s, I believe it was fishing elvers. And his case goes to the Supreme Court again. They win their case. And basically, if you hear about livelihood fisheries, that's related to the First Nations right to go out and fish for a modern life. That is the centerpiece of that. And so these two things really impact how the government should be doing and thinking about fisheries and science. Probably can't say one. Then we have Carl Walters, who is a fishery scientist from out in BC. Carl, in this period, he's forging arena theory, adaptive management ideas, and Carl has ideas that you should just go in, hit a fishery as hard as you can, see what happens, because we need to do an experiment. And then let's see, we'll figure it out after that. Adaptive management and ecosystem modeling. So Carl is a big influence, especially on the West Coast in terms of fishery science. But if you ever get to see Carl, Carl Walters is doing a lecture on fishery science, go watch it, because it will be entertained. He has a lot of hot takes. So post-1990s fisheries, failures in fisheries management really become front and center here. Can seafood feed the world? So are we actually going to feed the world, or are stocks all decline? Right? So are they going to continue to decline here out and from? And so then alternative ideas come up and creep up about how to avoid collapses and manage stocks better. And so two of the big ones that come out are the precautionary approach and ecosystem. So these are two big pieces that pop out of this. I'll talk a little bit more about both as we go on. And there's a continued erosion of faith in the government science and public service generally, just because of these collapses. It shook a lot of people's confidence. It shook fishermen's confidence in what we do, and even scientists were very keen on it. And then there's the great environment versus fisheries debate. This has been around. It's kind of similar to the density dependence versus environmental controls of stocks and populations that you see in ecology. It's been around for over a century. Is the environment driving this, or was it fishery? There was a push by some that the cod collapse was driven by the environment. So Jeff and Ram went in and did a really simple analysis. To me, this just highlights it. There's a change in temperature. There's what you did to the fishery, and then it collapsed. What do you think the cause was? To me, not to say the environment may not have had a role, but when you take a billion tons of fish in a few years, you're going to have a big impact, and a lot bigger impact than a small temperature increase. So Canada in the aftermath of the cod collapse, really Jeff and Ram lead the way here. They change how we think about these things, help with getting ideas around the precautionary approach put in place, I think. And they really made Dalhousie a leader in fishery science during this period. They were two of the big names. On the West Coast, we had big names too. So you had Carl Walters, who I mentioned already, his adaptive management strategies, ecosystem modeling frameworks start coming out here. And the other big name, probably I should mention, is Daniel Pauly. So again, he worked, I think, with Carl, from what I can understand, with the ecosystem modeling. First, he comes up with ideas of shifting baselines and fishing down food webs. So if you hear those two, I hope everyone has heard those two ideas. Really, they come from Daniel Pauly's work. And he becomes a bit of a media sensation during this period too, with New York Times calling him an iconoclast. You can get that done someday. You got another rare moment in fishery science, I think. And truly, so I was just pulling these numbers myself, and this isn't critical, but this figure up here is the export value of Canadian fisheries, with the dotted line being, and I did the, I don't know, I can't remember who it is, Industry Canada, let's say it's Finance Canada, inflation correction on this. So this is from FAO numbers, and just inflation corrected and how the government said we should inflation correct. 1992 is the dotted line popping down here. So that's when John Crosby goes in and shuts the fishery. What's really interesting is kind of been, other than 2 or 3 years, hasn't really changed much in terms of the export value from our fisheries. And you can see a couple of big hits there in 2008 and 2020. And I suspect everyone knows what the 2021 is. But so this is now the percent change in export value from Canadian fisheries. So this is how it changed every year. Here's the decline was about 6 or 7% in 1992. So it wasn't that big of a hit to the fishery in that year itself. And the 2008 financial crisis, which hopefully everyone was born for, yeah, everyone here would be, and the pandemic actually led to a bigger decline in 1 year than the closure of the cod fishery, which made me go, that's not what I expected to be talking about. So then I looked at the actual, I don't know if landings is the right word from the FAO website, but I looked at what the stocks did, and actually you do see that signal really strongly here. So 1992, again, this is the tons in live weight removed from the ocean in Canada, essentially. And what you see is you go from around 1.6, 1.7 million down to about 900,000 tons by 1995. So there is a really big shock to the system. This is just tons of live weight. It's probably corrected, but yeah, it's essentially think of biomass taken from the ocean and reported to the FAO by. And so you see, I don't think it includes agriculture. It's not. So anyway, you see that really big hit in the tonnage removed from the sea, and this explains why so many people have nothing to do in Newfoundland and Cape Breton PEI anymore, because you're just taking half as much as you used to, essentially, in 1 year. But it's really odd it doesn't have the export value, but we may be importing fish or something. I didn't get to on that. The other interesting thing is this decline that I'm thinking some people probably have paid attention to in the last 15 years, which doesn't lead to a change in our export value, because I think the value of the fish has been increasing. Lobster, scallop, snow crab, the fish that are caught are really high species. But it is interesting to see that decline from 1.3 million down to about 750,000 tons of life being removed from Canadian oceans. Yeah, that's a little bit. It's like FAO's everything, so it's everything we can there. Okay, so that's how we got here, but where is here? Of course, I'm going longer than I want to. So here's how DFO does stock assessment in 20 seconds. So stocks identified, someone goes, I need some advice from this from science. Okay? That's step one in the process. Somebody goes to science and says, okay, we need this advice. Usually it's a resource manager in DFO, but it couldn't be something else. So a request is made to science to provide science advice. Science goes, I got a lot going on right now. Can I actually do this extra thing you want me to do? Or is this something you always ask me? And so for commercially valuable stocks, usually annually, there's some sort of advice. For other things, usually the answer is, I don't have time because it's just me and you're not giving me more money to do this. So science gathers the data, usually runs some sort of assessment model on that. It goes through a peer review process which is organized by the Canadian Science Advisory Secretariat, CSAS. These results are all posted publicly on the CSAS website. Some of these meetings are open to the public, some are not. Depends, not details I want to get into. But really it comes down to someone asks science for something, we figure out if we can do it. If we can do it, it comes to a CSAS process, and advice eventually becomes public. So how do we figure out how many fish there are out there? Well, is there data from a survey? If there's not, then you got to use fishery data. You don't have much else you can do. If we have a fishery independent survey, yes, goes into some sort of model. End result is we get a biomass estimate. Now, if you're seeing somebody's doing an assessment using fishery data only, don't trust it unless you know they really know a lot about that fishery. I've seen meta-analysis done that are just wrong. And it's kind of like flipping a coin. If you're just using fishery data and you don't understand the fishery, you're probably going to be wrong. You might as well just flip a coin. I mean, is it good or bad? Just as much luck. And it's because the idea is the fishery data is proportional in some way to your biomass system, and it often isn't. And you need to understand the fishery. And sometimes it's not. So then we have what's called the precautionary approach. So that science advice comes out, we tie it to this precautionary approach idea, which again, tactical short-term advice, 1 to 2 years is what stakeholders care about. If the stock has reference points, and we're trying to get as many of them to have reference points as we can, but again, work, it takes money to do more work, so it takes time. And so then the biomass is compared to these reference points. I'll explain the 3 common ones really, really super quick. So there's this limit or lower reference point, an LRP, you'll hear it called. And basically below that, fishing is reduced to as low as level as possible. Doesn't mean 0, but fisheries should be reduced. Your worry here is you're going to cause critical harm, or you're approaching an area where critical harm. There's the upper stock reference point here. You'll hear this is the USR. Everything above that, green, considered healthy. So there, you then look at your removal reference point. This is this exploitation rate and say, okay, I can take this much out of that when we're in this healthy zone. And then between the USR and the LRP is this yellow cautious zone where you're going, well, not healthy, it's not about to crash. So we'll be careful here. We'll reduce our removal reference rate at some point. So we'll remove how much we're taking out of the ocean in some way down to as it approaches. So that's how they're managed. You can imagine before this, when this wasn't here, you'd have the same process more or less done. Science advice would come out with a number like 47. And it goes, is that good or bad? Well, it was 48 last year, it was 60. I don't know. Let's take 12. Like that's kind of what do you do when you don't have these goalposts? So they are really useful. They are not perfect. So now I'm going to shift to the future, talk a little bit about our research, and probably go 10 minutes over knowing me. So broad recognition that we should be doing better. So I want to talk about kind of 7 things that'll come up here. What better looks like is going to be incredibly variable. And so what do we do here? So there's a lot of interest in integrating new data streams and modeling frameworks. We have blue economy work that our lobster group's working on. Courtney is lead on some of this work. And socioeconomic considerations are really, it's one of those things we need to think about more. How is this, fishery and the economy affecting how they fish? Benthic mapping. So this is work we're doing with Craig Brown over in the SEED lab, which I'll talk about one sec. But this is Brittany Wilson has done this work. Get more back to that. Another one we've been doing, Raphael, who's over there. This is implicitly incorporating spatial structure, both to do our assessments, but how we think about how things, live in the environment. Accounting for movement, so immigration, emigration, metapopulations, technologies there through Ocean Tracking Network, but it's a lot of money, and it's definitely a challenge. Crowdsourced data, so Christine Ward-Page, who was a grad student here when I was here, she has this eOceans app, which is really neat. It was trying to collect crowdsourced citizen science and taking citizen science data. And again, in certain areas, especially like tropical where a lot of people died, there's a lot of data out there that we haven't been accumulating and using. Multi-species models is something a lot of people are interested in. And the last one is kind of integrated ecosystem assessments. So this is like, as I said, I do a stock assessment on one stock. I give you a number, done, thanks. The idea here is, well, let's get everybody that does anything in the ocean in your region together in one room. You tell me what you know, they tell me what we know, and we think about this ecosystem as a holistic system. And so to me, this is kind of a gold standard. The US is moving towards this. It is also can be thought of as a variant of ecosystem-based fisheries management. But yeah, it's really get everybody in the room, talk, and not just spit out one number here. So I hope we can move that way. But again, you have systemic structures that make that challenging. So again, I'm going to talk more about our benthic mapping work and our incorporation of spatial structure. And so Craig, who's over here in the SEAM lab, he's mapping the whole world, I think, at least the Canadian portion of it. And so Craig's work has really focused on a lot of mapping. He's helped us out in Bay of Fundy, which I'll show a lot of. A lot of his research there has led to us being able to develop these new types of models. But we're really focused on mapping as much of the ocean as we can right now. So then this is one example. This is from Brittany Wilson, as I mentioned earlier. So she's developed a benthoscape map of the bottom in the Bay of Fundy. What we have been able to do is take that information and develop a spatially explicit stock assessment method. And we is Raphael McDonald and Joanna Mills Fleming. So that's work we're collaborating on with Joanna and her expertise and her network of really amazing fisheries scientists across the world. And so what we do is we're taking the maps, combining them with new statistical methods, and coming up with brand new products. And so Raf, now we should have our third paper out on this very, very soon. But essentially we now have spatial information into our stocks. You can see here, for example, in 2002, we saw there's a lot of biomass here. In 2018, the biomass is spread out across the whole area. When we run the model, there's the same amount of biomass in these two things, in these 2 years. But they get there in a very different way. When we don't account for space, actually this overestimates the biomass and this seems to underestimate the biomass. So these spatial methods have a lot of applicability and better understanding what biomass needs, which is what I need right away. But they also are very useful for future ideas, which I'll do in a sec. We've been exploring spatial variability in input parameters. So this is mapping how meat weight, the size of scallop change. This is SPA3, Yarmouth's around here somewhere. And so what we see is essentially, this area has very high meat weights. This area has very low meat weights. What we want to do is include that into our modeling framework. And we're also looking at how that varies seasonally. So we know spring bloom period, the scallop tend to get a little bit fatter, for example. So we know there's more biomass in June from each individual in July for every individual they take than there is in November because they spawn in the fall. And so we also want to look at taking into account spatial and seasonal variability effectively in what we would call productivity. Here we explored, this is a sea cucumber project we're working on. And so what we saw here is generally, these are 3 different ways you can model space. They all kind of give you the same answer, more or less, so they're quite similar. But when we actually don't model space, so we have a non-spatial model, you get a very different answer. You can see from the colors, this is essentially your catch rates. And what you see is your catch rates are much, much higher in these marginal areas when we don't account for space. And these are just models with the exact same environmental covariance in them. And so that can be a big problem, right? If we're trying to estimate the biomass of this from this non-spatial GAM, we would say there's way more biomass here and in different places than we account for space. And even the directionality of the environmental covariance are different. So this one says the bottom stress, it's a measure of mixing on the bottom. This says as bottom stress decreases, we get less sea cucumber. This says as bottom stress increases, or we get more cucumber. So you're getting actually the opposite pattern of the model, whether you account for space or not. So serious implications for what we're doing. I'm going to skip this one. Sorry, Nancy. So scientific challenges that we face. Cautionary approach isn't perfect, but it seems useful to me. I think with these spatial methods we're developing, we could talk about area-based density metrics, for example. So, an LRP could be, oh, there's only 300 kilometers with this much density left. So that's a potential new way we could look at that. Are we locked into single species paradigms? And is that a bad thing necessarily? Again, I think with integrated ecosystem assessment tools, we can still do single species assessments how we've traditionally done them, but use that information within a broader framework without trying to force an ecosystem perspective into that model itself. My struggle with ecosystem frameworks is we don't actually know how biology and environment interact to impact ecosystem dynamics. It does. You always just say temperature and shrug your shoulders. So how do you manage something when you don't know how changes to the system impact the system? Oh, the animation's not done. To me, I think one way was just come around very, very recently to help people talk about is risk assessment frameworks, where we can actually project out what different environmental scenarios look like on the status of the stock, and then manage that based on this risk assessment from different assumptions, which take into account the likelihood of something happening and consequence. So is it really bad? Is it really likely? You think about that, and you manage to stop around that. And we need to also remember that we only control fishing effort and removals. So if we talk about rebuilding plans, that all means we just stop fishing It's not like we're doing anything else. We stop fishing and pray. No, if you pray. We stop fishing and hope otherwise. And so this gets to one of my favorite things Donald Rumsfeld ever said. No, never thought I'd put this. But the delusion of control, it's not his idea, but and that is, you know, we don't have much control over these ecosystems once we take fishing out of the equation. It's just going to do what it does. And so there's a lot of things we know, it's knowledge, but there's a lot of things that we don't even know we don't know, right? So there's aspects of ecosystems that are controlling things that we aren't even aware of. Right? Lots of other things that we think we know, it's bias. We think we know what's going on. I know what's going on, but we're wrong. That's a piece. And then there's things we know we should be worried about. We don't know how to deal with. That's where I think stuff comes in. No, we need to think about it, but we don't know how. And then there's the perceived need to integrate everything to properly manage stocks. So let's throw everything at it and sort it out. And so we only have so much capacity and money in the universe. So to me, it's kind of a prioritization to figure out what the most important things are we need to be focused on. Other systemic challenges. So there's training. So this field, fishery science, is multidisciplinary by nature, and there are very few places to get the training done. University of Washington is the one place that always comes to mind. The field's really quantitative. I bet you not many people in here are excited about ecology because of the math. I kind of was, but most people aren't, right? And so math isn't what gets people into the field. So they go, not really interested. But you need to be quantitative, but soft skills are super, super important in this field too. You're working with First Nations fishers, NGOs, lobbyists, foreign governments, all sorts of very delicate relationships that you, as the person running this model, may have to oversee. So you need a very interesting combination of skill sets. And I will say that we've done very well in getting more women into science, but I think the diversity of other perspectives are still, there's still a lot of white guys that be out there. From a funding point of view, you hear all the time, if you're paying attention to the budget, we're probably all going to wind up that, oh, we don't have the resources to do that. But we really have a lot of resources. If you're an ecologist and you see a fishery vessel go out, you're like angry. You're like, we get so much money. So the key is spending your money thoughtfully, stop throwing money away for the flavor of the day, have a plan, thoughtful, stable, nimble, long-term scientific vision is what we need. And there are people that might go, this isn't really a strength of a management body or a government, right? Long-term vision, but short-term demands don't match. So there is talk out there of the need for an independent scientific body that provides advice to government science. And that's an interesting new idea. No, not new probably, but it's an interesting idea that's a need. So I have done almost. My conclusions are essentially, I don't think the sky is falling. I don't think the sky has fallen. But we face a whole lot of challenges in fishery science. And they are very complicated, multidimensional, high level. And what we really need to do better than we did when the American Fishery Science came up with this is have everyone collaborating together to prioritize what we need to address and then address the questions. That is it. Thanks to a whole bunch of people. Oh, one more thing I should say. So thanks to everybody who I've done science with in the last bit and was involved in this, the science presentation part. Thanks to everybody that has hung out with me over the years. And thanks to Jeff. I should not stop this without acknowledging Jeff's influence on everything I think about. Probably have a Jeff thought every day. I'm like, oh, what would Jeff think of this? He'd tell me that the fishery is all that matters. So pay attention to the fishery. So, yeah, I'd probably still be out west studying dirt without Jeff. His influence has been, he's a great mentor and really missed. Last thing I will say is Laura Weir, and she invited me, which was nice, at CCFFR, which isn't called CCFFR anymore. I don't remember the name of the conference is in February in Fredericton. The new conference, the Canadian Aquatic Society, hopefully we'll be having the seminar. People may get picked to come give a presentation. It's just in a memorial presentation to Jeff. So that's hopefully coming up in February. That's it. I think that's only 10 minutes longer. No, not even. Okay, cool.